Good morning, student. Today we will start again the chapter 8 motion science of class 9, and the topic we will cover what are the different type of equation of motion, and graphically we have to prove it. We know it very well that when an object is moving in a straight path, then it has acceleration, velocity and distance. It means there is a relation between acceleration, distance and velocity with respect to time, and that relation we will verify by graphical method. And what are the different type of equation of motion? First equation of motion, v minus u is equal to at. This is the first equation. First equation of motion. This is the first equation of motion. Second, s is equal to u t plus half a t square. Second equation of motion. Second equation of motion. And the third, 2as is equal to v square minus u square. Third equation of motion. Here are the three equations, and these three equations we will prove graphically. And now the symbol which we are using, what is the meaning of this symbol and what are their units? Now first, u is initial velocity, unit is meter per second, v final velocity, unit meter per second. Third, a acceleration, unit is meter per second square, and this we can write m as minus 1. This will be minus 1. When we change denominator into numerator, then the power will be negative, or negative power will be positive and positive power will be negative. M as minus 1. Here is m as minus 2. Whereas t is the time, unit is second, and s is distance or displacement. Distance or displacement, unit is meter. These are the unit and the symbol which we will use to verify this equation by graphical method. And for calculation or for numerical problem, what is the value of v, u, and when object, I think I already explained you, about to start, u equal to 0, come to rest, or applied break, v equal to 0, moving. Third point, first, second and third, moving with uniform velocity, means v minus u equal to 0 or a equal to 0 for numerical value, for numerical problem. When we will solve the numerical problem, then we have to keep these points in our mind. And now first equation of motion is v minus u is equal to at, and we have to verify. And how we can verify? Please check it carefully. Now the first equation, graphical method first equation. This is the graph between velocity which is taken as y-axis and time which is taken along x-axis. Velocity time graph represent the acceleration, and this straight slope, I think you have done in graphical representation, this straight slope in velocity time graph, in vt graph, straight slope, slope we can say, slope will show uniform acceleration. It means the object moving at a uniform rate. It means rate of velocity is uniform, due to which this slope AB represent the acceleration which depend on this y-axis and this x-axis. This is 0. It means when the object will start from here, if the object will start from here, that if the object start from here, then u equal to 0. But here the object start from point A. The object is not start from O. If the object start from 0 O, then the initial velocity will 0. But the object start from A means it has some initial velocity which is equal to u. It means u not equal to 0, means u not equal to 0, u not equal to 0. When the object having the initial velocity v u and increase its velocity v at point B in a given interval of time t, means the object at point A having velocity u, which is initial velocity, and this object increase its velocity at a uniform rate, and the velocity after time this a to b the time taken is t, the velocity is increased to v, and this velocity is increasing at a uniform rate, mean acceleration is uniform. Therefore AB is represent the acceleration, and this y-axis represent the velocity, and x-axis represent the time. And OC is parallel to AD. OC is parallel to AD. It means if OC is equal to T, then AD is also T. We can say that OC parallel to AD. Parallel means the distance between CD and AO is same. It means AO equal to CD, OC equal to AD. And from here B, draw B, E perpendicular to y-axis. It means BE parallel to AD parallel to OC. We can say OC is equal to AB. And now similarly OA is parallel to DC. It means if DC is equal to U, OA is equal to U, so DC is also equal to U. Then OC is equal to AD is equal to T, and OA equal to CD equal to U, and BC equal to BC, here is BC equal to BD plus CD. This BC equal to BD plus CD. What is the value of BC? BD plus DC. BD plus CD. And now what is the value of BC? BC is V, this BC, B C. This is V. This is V. Final velocity. V is equal to BD plus CD, which is equal to OA. OA. And V is equal to BD plus U, and this is plus, and we will change the sign. So this means V minus U is equal to BD. So what is BD? BD is change in velocity. Change in velocity. And this acceleration slope AB is depend upon the y-axis and x-axis. Mean acceleration is equal to change in velocity upon time. This will be A. Acceleration is represented by A, and this change in velocity BD is the change in velocity. BD upon में what is time? T. Cross multiply. Then BD is equal to AT. What is the value of BD? BUT from first and second. From first and second, this BD is equal to V minus from first and second. BD, V minus U is equal to A into T. This is the first equation. Whereas V is the final velocity, U is the initial velocity, A is acceleration, T is the time. From here we can calculate the value of A. That means from here we can find out A. A is equal to V minus U upon T, or T is equal to V minus U upon A. These are the formula which are drawn from first equation. V minus U is equal to AT. If we divide A, then we will get the value of T. If we divided T, then we will get the value of A. This is the first equation of motion. It is clear? And again, velocity time graph, this slope represent the acceleration. Represent the acceleration. It means when an object moves in a straight path, it has a uniform acceleration, means increasing its velocity in equal amount in equal interval of time. If the velocity change in equal amount in equal interval of time, then the object is having the uniform rate of velocity, and rate of velocity measure the acceleration. This is the first equation of motion, which is equal to V minus U is equal to AT, and V is already mentioned to you in previous point. V is final velocity, U is initial velocity, A is acceleration, T is time. Unit of V meter per second, unit of U meter per second, unit of A meter per second square, unit of time is second. In this way, graphically we can verify the first equation of motion. And now we will prove the second equation of motion, which is equal to S is equal to UT plus half AT square, and note it down. Equation of motion by graphical method, the second equation. In the second equation, you know S is equal to UT plus half AT square, which is also known as position time relation. Position means S distance, how much the distance covered by an object in a given interval of time. And in first equation, V is equal to V minus U is equal to AT. It means velocity time relation. And for this, when an object move from A to B, in which the rate of velocity is uniform, having an acceleration A, it covered some distance S in a given interval of time T. Then we know very well, in VT graph, the area under the curve or the area of enclosed figure in given VT graph is represent the distance covered by an object. If the object is start from A and reach at B, and then from B we draw perpendicular to x-axis, and from A perpendicular to x-axis, then it form a closed figure. Start from A, reach to B, and when we draw perpendicular from B and from A on x-axis, then it form a closed figure which is known as OABC. And this area of this closed figure represent the distance covered by an object. And then how we can verify the second equation? It means it is also known as position time graph. Then object covered a distance s in a given time t under the uniform acceleration a, then the distance covered by an object is the area enclosed with an AAB in VT graph. VT graph means velocity time graph, or we can say VT graph, V dash T graph. Then area OABC. This area equal to, what is this? Area of which one? Area of OADC. It is rectangle. Area of rectangle plus, what is this? Area of triangle. Area of rectangle area of rectangle OADC plus area of triangle ABD. And now you will think that sir is calculating area of rectangle plus area of triangle. Why I am not applying the formula of trapezium? For this second equation, we need to find out the area separately. And then area is covered, which is equal to S. We know it very well. This is S. Is equal to area of rectangle half base into height. Base into height. Sorry, base in area of triangle half base into height. Length area of rectangle length multiplied breadth. Area of triangle half base into height. Length or breadth. What is length? We will take this x-axis. What is this? T. And what is breadth? Breadth is u. Plus half. What is base? First we will take OC into CD. Plus half. What is base? AD. Into height. What is this? BD. S OC, which is equal to T. It means OC into CD is equal to OA plus half AD. AD is equal to OC and BD is same. And then S is equal to OC is equal to T. OA, the OC is equal to T. And OA it is equal to U. It is U. Plus half OC is T and BD we know in first equation. In equation first, BD is equal to V minus U is equal to 80. So BD is equal to 80 into AT. Then we multiply. We can write S is equal to UT plus half A T and square. This is the second equation. And you know the symbol S is the distance covered, u is the initial velocity, t is the time, a is acceleration, and t is the time. This is the position time relation which represent the second equation of motion. And now the third equation of motion we will prove, and note it down.